Alright, what do we need to do?
So we need to find the height of one of these triangles.
Okay.
Well, the height of this triangle here, maybe we could use that since this is a nice number, 10.
Okay.
So
I'll erase that 16x so it doesn't get in your way if you're going to work over there.
I'll call this Z.
Alright. So you call the height of the triangle whose base is 10, the height is Z. Okay.
So this is a 45-degree angle.
Yeah.
This is also a 45-degree angle.
Yeah.
So this here, this is Z. And this is 10 minus Z.
That's 10 minus Z. Okay.
So, actually another 10 minus Z, since we have a 10 up here, looks like another 10 minus Z would be the height of our little triangle.
Okay. So that's interesting. So that means if I replicate your drawing over here, the height of this triangle, the little triangle, whose area is,
It's X.
and the height of the big triangle, whose area is,
It's 10 minus, it's Z.
so this is, the height is 10 minus Z.
Yeah, the height of the big triangle is Z.
Okay.
So, now we could say, if we wanted to find an equation for X, we could say 2.5 times 10 minus Z times 1/2 is X.
Okay. That's right.
So, we have two variables and only one equation.
Yep.
And then we could do the same thing for the big triangle.
Okay. What would the equation in the big triangle be?
It would be 10 times Z would equal 16X.
How come?
10 times Z times 1/2.
Alright, so that's interesting. So you have 2.5 times 10 minus Z times 1/2 equals X, and you have Z times
10
10 times 1/2 equals
16X.
16X. That's interesting.
So to figure out what Z is in terms of X, this equation looks a little easier.
Yeah. We could plow through these. We got two equations and two unknowns. We could plow through it. Let's see if we can go to some geometry. Okay. Let's look at the geometry. This will get you there, by the way. This will get you to the finish. But I want you to see the geometry instead. What can you tell me about the relationship between the two blue triangles over there?
So this big triangle and that big triangle are not quite big, but
Yeah. What's the relationship between those two triangles?
well, they're similar to each other.
True.
And this triangle is 4 times as big as that triangle.
What does that mean?
It means all the sides are blown up 4.
Okay.
So 10 minus Z, guess I have to write in the triangle, times 4 is Z.
Okay.
So here we get 40 minus 4Z is Z. 40 is 5Z. So Z is 8.
Z is 8. What's 10 minus Z?
2.
Okay.
So the area of this triangle is 2.5. So 60 times 2.5 is 150.
How about that? So you did the same thing over here.
As we do with the Y.
Right. So the relationship between that height and this height was 4 to 1. Because this triangle was, the sides were 4 times as big. And they have to add up to 10. So it's 8 and 2. This triangle, the relationship was 3 to 1, and they had to add up to 10, so it was 2.5 and 7.5. So it was really the same thing. It was finding this relationship, that got you to 60. And then this relationship here told you what this area was. Pretty cool.
Yeah.
So you were super, super close to solving this. You had to do the same thing basically over here that you did over here. Notice that it added up to 10, and the ratio of the side lengths was 4 to 1, or sorry, 4 to 1. Here it had to add up to 10, and the ratio was 3 to 1. It's just the same thing.
Yeah.
It's pretty neat. This will get you there too, by the way. You chug through this algebra and get there, but that's the geometric insight is noticing that the thing you have to do over there is the same as over here. Pretty cool though. Pretty cool though, right?
Yep.
That's a good problem.